Good morning, students. Teacher Betty, continuing with the advanced inorganic topics, lesson 8. In lesson 7, we looked at inorganic polymers containing phosphorus. Today, we are going to look at polymeric cations and the anions. Nomenclature of isopoly anions. Isopoly ion acids are obtained by condensation of molecules of the same acid. The anions derived from isopoly acids are called isopoly anions. These anions are named by indicating the name of the atoms of the characteristic element with the Greek number prefix. An example, we use the di, tri, tetra, as the case may be, and so on. Remember, this is how we used to name the boranes. An example is S2O7 to non-negative. This one is called a disulfate ion. Di means 2 sulfur atoms. Then P3O10, 5 negative. This is a triphosphate ion. We have 3 phosphate groups, phosphate atoms, 3 phosphorus atoms. Then the MO7O24 negative 6, it is an heptamolybdate ion. B4O72 negative, it is a tetraborate ion. And then CR4O18 negative is a tetrachromate ion. We have 4 chromium atoms. Isopoly ions having cyclic or ring and straight chain structure are distinguished by using the prefix cyclo for cyclic and catena for the straight chain structure. An example is this. This is the cyclic structure. So we name it as cyclotriphosphate ion. And this is a straight chain. We name it as the catena trisilicate ions, and so on and so forth. Nomenclature of heteropoly ions. Dinuclear ions are named by considering the anions which occur first in alphabetical order as a ligand on the atoms of the second anion. Always indicate the oxidation state of the anion at the end of the name. An example, this molecule can be named as phosphato sulfate -3. -3 is the oxidation state. Then this one is called acenato phosphate -4. -4 is the oxidation state. So if the structure is in this form, it's called acenato chromate sulfato phosphate -4. Cyclic heteropoly anions are named in a manner similar to the previous one. The starting point and the direction of the citation of various units are taken in alphabetical order. An example is this: cycloacenato chromate phosphato sulfate -2. -2 is the oxidation state. So we are following the alphabetic order. Acenato, C is the one which is next, chromate, phosphato sulfate. Condensed heteropoly anions consisting of 3-dimensional framework of tetrahedral link and the surrounding central atoms are called by using the prefix molybdo, tangeto, and etc. An example are these molecules. These ones are called, this one is called 18 molybdo diphosphate -6. Remember to write the oxidation state at the end of the name. So this one is having -6. 18 molybdo, we have 18 molybdenum atoms. Then diphosphato, there are 2. Di means 2 phosphate atoms. So the name will be 18 molybdo diphosphate -6. This one will be dodeca tangasto phosphate -3. Formation. Mechanism of formation of these cations and anion in aqueous solution. They are formed from cations in solution. The aquatic ions undergo protonic acid dissociation, whose dissociation constant decreases at every stage of dissociation. On dissociation, the system produces ions of decreasing electron density, increased the electron density, and then go on losing the proton. They change from cationic to neutral and then to anion. The illustrative example is shown in this slide, where we hydrate a chromium. So they go on decreasing by losing a proton to neutral and then to the anion. A point to note here is that the formation of an ionic species is favored by increase in pH. Such a reaction may proceed to a stage where the diminishing charges on the hydrated cation permits the formation of an oxobridge or hydroxobridge polymeric species. The polymeric cations and anion can also be formed from mutual interaction of 2 aqua hydroxyl complex. This produces a binuclear complex where a group of water of a mononuclear complex is displaced by a nuclear hydroxy ion. So the group of water on condensation is replaced by a hydroxy ion. So there is a loss of a water molecule. Always remember the condensation process leads to the ratio of smaller molecules like water, ammonia, hydrogen chloride, as the case may be. They can also be formed from anion of a phthalic transitional metal in aqueous solution. And examples are the group 5A and group 6A metal species, especially the vanadium, molybdenum, and tungsten. If the pH of the solution of these ions is lowered, they undergo reversible condensation or polymerization reaction, as can be seen in this equation, where M is a vanadium, a molybdenum, or a tungsten. A point to note here is normally polymerization is preceded by elimination of water molecule. The polymeric ions can also be formed from oxo acids or oxo anion and oxo anions. That is, they can be obtained by thermal dehydration or the oxygenation of the solute or their acids, and then polymerization. The polymerization is more pronounced in oxo anions of weak acids, and the tendency to polymerize decreases in the following order, where the silicate is greater than the phosphate, greater than the sulfate, and also the chlorate. The tendency to polymerize decrease with the increase in the charge density. That is, the tendency decrease due to the fact that the coordination site at the anion of oxygen also decreases, as can be seen in this slide. Polymerization decreases the overall charge density. When you look at this, the starting material, we have 8 charges, but as the polymerization continues, it results into a decrease in the overall charge density. We have 6 charges. This is due to the fact that the coordination site at the anion oxygen also get decreased. Stability and solubility of the heteropoly anions and isopoly anions. Many of these heteropoly ions and solids of their ions are very stable in water and oxygenated solvents. Their acids are usually stable and strong in contrast to the isopoly acids. They tend to undergo depolymerization to form oxides. Applications. High molecular weight phosphate or condensed phosphates are able to adjust the pH and to complex water hardening ions such as magnesium ions and calcium ions, and keep them in solution in presence of a precipitant. This property finds application in water softening. Heavy-duty powder detergents contain at least a third in weight of sodium triphosphate as water softening and dirt disposal agent. Isopoly and heteropoly anions are used as catalysts for the selective oxidation of organic molecules. And many polyions have been used to function as ligands. Next time, we are going to look at stabilization of oxidation states of transitional element or transitional metal elements.